Okay, now a totally new data set. Let's talk about diabetes, which, by the way, we talk about COVID right now, but a lot of other concerns have been popping up across in terms of epidemics, and one of which is a true drug epidemic, which, I don't know if, and what I mean by epidemic is I just mean deaths caused by drug-related problems. And then in addition to that, there's another one that the CDC has been looking at. So they look at diabetes, because that's spreading, and they look at the drug one. Now I hear a lot about too. Oh, I'm forgetting about. There's another one that they're looking at too that I just, for some odd reason, it's not coming to mind now. But anyway, so let's look at diabetes. And this is based on the National Health Interview Survey. So we have an age group, and this age is used to represent the group. So that makes sense. 35 to 39-year-olds, we're going to use the representative of a 37-year-old. 2% of the nation in this age group, 2% of that age group has diabetes. And then right around 42 years old, about 4% of that age group has diabetes, etc. And then as you age, right around 67, about 14% of 67-year-old grouping of age has diabetes. Okay. And this isn't just happening in our nation, just to give you a little bit of tidbit. But you could look at that in another class for sure. Okay. Create a scatter plot. All right. So, of course, we begin with stat, edit, and I have put this into list 5. So there's the age representation for that span of 4 years of life. And here is the percentages that correspond, remember, so they have to line up because 2% corresponds to this age group of 35 to 39-year-olds. Okay? So now we go to y equals, and we're going to clear out any old things, and we're going to go to second stat plot. We're going to turn it on. Excuse me. We're going to create a scatter plot. That's going to be of list 5 and list 6. And then, of course, we go zoom, and we go all the way down, so arrow down again to zoom stat. And here's what the data shows us. Yeah? Okay. So let's take a peek. This data is a little bit old. Sorry to say, it's about 2 years old. So 2 or 3 years old. But that's actually not that old in terms of data. Let's create our scatter plot and graph here. Okay, so some decisions were made. Oh boy. Ouch. In terms of my first line being straight. Ouch. First, I decided that the percentage is a response to age. So that the age responds that percentage of people, the percentage having diabetes. So I put that, so I had put this into list 5 and I put that into list 6. So I had already made those decisions, and the explanatory then goes along the horizontal axis, age, and percent with diabetes. Got it. And now we draw our rough sketch here. And then, so let's see, I have those first 3, and then it's a little bit higher, and that. Got it. Okay, rough sketch. So I really just, okay, you can't see it. So here it was for real, and then there's my rough sketch of that with labels. Create a model. So here we go again with this model. Well, like before, we have some decisions to go about this. So, okay, is it linear? It looks pretty linear to me, to be honest. Okay, is it linear? Is it quadratic? I don't see much curvature. Exponential and inverse variation. So immediately I just said no to all of these three because it's not curving. Yeah, not really. It's not really curving. So that's why we picked this model. Okay, so that means we are using LIN, linear regression. Got it. So that means the percent with diabetes is going to be approximately, and here we go. Whoa. Okay, so we go stat, calculate the linear regression model. This is list 5 and list 6, and we're ready to rock. Okay, so it looks like we have an initial value of negative 13.9143, and we have a constant increase of 0.4214ish. Okay, let's jot that down. Okay, the initial value is about negative 9143, and it's going up by 0.4214 each age. Let's call it A for age. Okay, so for each year you age, it's going up by about 0.4214%. P equals percent. Percent of age group with diabetes. And A equals age of the person. Okay, so graph your model with the scatter plot. So we go back here, and we go to y equals, and we put in our model, which of course I have hidden from myself. So negative 13.9143 plus 0.4214x, and we graph. Yeah, I feel like we have picked the right model here. This makes me feel good about our decision. It misses this one by a little and misses this one by a little, but I can see that their error kind of offset. This one's a little below, this one's a little above. Really good fit. I didn't look at the correlation coefficient. Probably should have. So graph your model on the scatter plot. It looks like it goes through most of them except this one and this one. So I don't know. I have a ruler here. This is really based on how good of a sketch artist I was. Okay, something like this. Yeah? All right. Rough sketch, because I did that by hand. Okie dokie. Use your model, of course, to predict the percentage of 47-year-old. Okay, it says Americans, but really I'm starting to use this phrase less and just say people who live in the United States. 47-year-olds who live in the United States with diabetes. Okay, so that's our P. P equals 47, and let's use our model. Okay, so 47 equals negative 13.9143 plus 0.4214a. I'm going to add 13.9143 to both sides. So let's see, 47 plus that is 60.9143. So that means that this term over here, right, this plus that makes 47. So this had to have been 60.9143 in order to be able to take away this 13.9 and end up with 47. Now I am going to scale. Divide both sides. Scale this by 0.4214. Okay, and that means the age will be approximately, so 60.9143 divided by 0.4214. I just realized that I said this was 47% and asked for the age, but this says 47-year-olds. Oh my gosh, it gave me the age. What kind of silly person am I? Okay, so I'm actually just going to correct this instead of restarting this. That might seem strange to you, but sometimes we make some serious mistakes and we just go back and we fix it. So let's do that. Let's just go back and fix this flaw. By the way, I got a ridiculous answer of 144 as the age, which, okay. I mean, in terms of the age and the percentage, makes sense, but as soon as I realized that the age was 144 years old, I was like, I have definitely made a mistake. This is the age. The age was 47. So the percent is equal to this times an age of 47. I made my life harder for, darn it. Okay, so here the percentage is approximately negative 13.9143 plus 0.4214 times 47 times. So that is percentage of about 5.9. Okay, so the estimate was about 5.9%, and then it says show how much error. Okay, well, for a 47-year-old, it's actually 5% of them. Oh, okay, so the model had an overestimate. The model overestimated by 0.9%, by about 1%. Okay, in terms of preparedness and making sure we have everything that we need in order to help people with diabetes, this is a good number. In terms of talking about our population and being concerned about them, maybe we're being a little too concerned. Well, I don't know. That's a lot of people with diabetes. Use your model to find the age of people in the United States, where about 7% of them have diabetes. Okay, so now that's where P equals 7. Ugh. Okay, I will not forget that I made that mistake. It's much easier to actually write down what each number represents and get it right the first time. Okay, so the percentage is 7. 7 equals negative 13.9143 plus 0.4214 times the age. Okay, that means this is 20 something. Yeah, 20.9143. 20.9143 has to be equal to this 0.4214 times A in order for this to add to 7. And then scale down. Okay, so scale each side by 4214. Point. Okay, so then age is approximately, okay, so we have 20.9143 divided by 0.4214. All right, That makes a little more sense. 49.6. Okay, use your model to find the age of people in the United States where about 7% of them have diabetes. Show you how you found this. The age is about 50. And if you look up here, 7%, that is somewhere right here. And it makes sense that we ended up with 49 or about 50 years old. Okay, so about 7% of 50-year-olds have diabetes, according to the model. Use your model to find out how many people in the United States your own age have diabetes. Okay. Now, that means that you yourself are going to put in your own age, insert your number here, and find your percentage. Yeah? For me, I feel like this is a little bit, you gotta take care of each other, you know? So, I don't know what you're becoming, but nonetheless. So we look at this model of diabetes and we see that it is on the rise, it is increasing. We didn't really talk about its growth rate, which we could. Previously, when we look at lines, we talk about how much it's increasing or decreasing, right? As you age by a year, it's going up. This percentage of how many people of that age have diabetes is increasing. Okay? So there's our linear model.